Alright guys, I am back with part 3, and for this one we need to add another variable to our blueprint character or BP char info blueprint interface. So if you go to your third person blueprint and go to your blueprints folder and just open that up and select your get essential values function. Then on the end of this, we're just going to add one more here for now, and we're going to call this aim yaw rate, and this would be a float value. Compile and save it. Then open up your third person character blueprint and go into your interfaces here and right click and promote this to a variable and just move it over here like so. Now go to your tick graph. Well, actually, let's create a function first. We're going to call it catch values, and off of this one we're just going to say we're going to duplicate this one. This one's going to be called previous aim yaw rate, or previous aim yaw, I should say, sorry. And then we will set this one here, and this one is just going to be the control, let's see, get control. Just right click here and say get control rotation. Split it and just plug up the yaw or the Z value here to it. We'll add one more to this later, but for now that's all we're doing. So go back to your tick event graph, drag out your catch values, and you want to catch it after this set essential values has been processed, because we need to do another calculation in here. And I am going to drag off my aim yaw rate and set that here. And so we need to get the control rotation. So we're going to get this current control rotation. We're going to subtract it by, actually, yeah, I messed up on this. Well, we just need to, never mind. We just need to subtract the Z off of this one. So float minus float and previous yaw, previous aim yaw. Yeah, that's right. And we are going to divide this by world delta seconds, or get world delta seconds. And this is going to be our aim yaw rate. So what we're doing is we're getting the current Z rotation. If you're looking down from above the player, then the Z rotation is the rotation around the character as the camera is moving left to right. That's your rotation on the Z. So we're subtracting that from the previous one and dividing it by world delta seconds to get the aim yaw rate, or I should say the rate at which our aim yaw is changing over time. So just compile and save that. That's all we needed to do there, I do believe. We will come back if I missed anything. So back over here, okay. We need to go to update char info and we need to promote this to a variable. And save that. And now I'm just going to, while we're here, let's go ahead and hook this up. So just type in base layer, or I mean linked anim layer. Select it and then come over here to the settings and change it to base layer and plug that in. Now we are going to go into the TurnInPlace check function that we created earlier in the first video. So let's see, we need to get the aiming angle. We need to split that because we only need the X, which, if you remember, update aiming values, the X is the yaw, the rotation around. So we need to get the absolute value of that. So if it's negative, it'll be positive. If it's positive, it'll be positive. So that we can check to see if this is greater than 45 degrees. And these values are kind of already calculated. These are the values that ALS uses, but basically it's saying if this is greater than 45 degrees in either direction, or I should say 45 degrees, if it's greater than 45 degrees and, let's see, and our aim yaw rate is less than 50, then we'll continue on with the TurnInPlace check. So if he's not looking forward, okay, and he's turning at such a rate, or he's turning slowly, yeah, if he's rotating his view around the player slowly and he's not looking straight forward, then we'll go ahead with our TurnInPlace check, or we can turn in place, but we're going to use a timer. Now the reason why he does this, the aim yaw rate, and is because, let's say that the character is just sitting there and he just wants to look behind him real quick. If you didn't have this in place, the character would just start turning in place and it would follow along with the mouse, and that kind of looks unnatural. So I don't know, it kind of makes gives the character more of like he has a mind of his own. So that's why we're doing that. Now right here we need to get our elapsed delay time, or yeah, we need to set it, I mean. If that's false, then we want to reset this this timer, and then we want to return. And we can move this down some. So if it's true, we want to get the elapsed delay time, and we want to add it to the delta time X. So get delta time X. Remember we set that at the very beginning, one of the first things we did. Hope you didn't miss it. If you did, just go back to the event graph and right click on this and promote to a variable, or drag off of it and promote to variable. So that will be our new elapsed delay time. So we will set this to be our new elapsed delay time. What this allows us to do is it allows us to have a delay between turning, so that if the player looks to the left real quick and then looks back to the right, it won't turn immediately. It'll wait a bit, you see? So even if he is moving, looking slowly to the left, he still has time to look back to the right before it will turn in place. And you'll understand more here in a little bit. So we need to get the aiming angle again. And again, we are using the yaw, or the x value in this case, of this 2D vector. And we're going to get the absolute value, and we're going to have to map it to a range. Let's see. So get the absolute value. And let's see, we need to see if this is greater than, so get the elapsed delay time. Actually, no, I'm sorry. Let's map this to a range. Map range clamped. Yeah. Okay. I don't know what I was thinking. So we will get this elapsed delay time though, and I'll see if it's greater than this. Then it'll be branch. Okay. I will shortly explain to you what we're doing here. So, and you can promote these to variables. That's what they did. And if you want to know, just go and look at their version of the function, and you'll see what they did. But basically, if it's in a range of 45, or it can only be in a range from 45 to 180, so it'll clamp whatever value this is, the absolute value of the angle that they're at on the Z, and they'll clamp that to a value between 45 and 180, which is obvious because they have to be greater than 45 to pass this check in the first place. So we know it's going to be between 45 and 180 because we're getting the absolute value in 0 to 180 to the right and 0 to negative 180 when turning left. And so we want to map that to a range of 0.75 to 0. And how did we come up with those numbers? Well, I will break it down for you. So if you divide 180 into 4 parts, so if you get the calculator real quick, you divide 180 by 45, you'll see it fits perfectly, and it can be broken up into 4 pieces. So since we're starting at 45, that's 75%, and 180 is going to be 0. So our elapsed delay time, if it's greater than whatever value that falls between 0.75 to 0, then that means that we've been waiting long enough to where the aiming angle is greater than or is less than the elapsed delay time. So eventually it will be. And what the effect this has is it allows us to have a different delay from front to back. So if we're looking to the left, it will have a longer delay for rotating left than it would be if we were looking back here. So if we were looking almost directly behind the character, or we were looking directly behind the character, this value would be around 0. So the elapsed delay time would pretty much be guaranteed. Well, actually, it would be guaranteed to be greater than 0. So with that being said and out of the way, we need to make one function here, and we're going to call it turn TurnInPlace, and it needs one input value, and we will call that target rotation. Yeah, and that will be a rotator. So back over here, we will drag this out, and we will plug it in here, and just ignore all those other values that they have as their inputs on theirs, because I'm not using them, because I found it easier just to make things more clear, and easier to make things more clear along the way when I can explain these values to you, because in their case they're not really changing these, but they added those extra values in there to make it more like compatible for, like, you could take this and use it somewhere else, you know, stuff like that. Anyway, moving on. So we need to get the aiming rotation. Okay, so let's get the aiming rotation, and we need to split it, and we need to split this, and we're just getting the Z value. So it'll make more sense here in a minute while we're only getting the Z value. So do a sequence off of here. We will have 3 of these. So for the first one, we need to create a local variable. So go down here to the very bottom of your list where it says local variables, and press the local variable thing. We are going to call this turn angle, and this is going to be a float. So we are getting the float right there. You can just type in RER and add reroute node if you want. It's up to you. We are going to set this right here. And this is going to be the angle between the target rotation and the character rotation. So right click and say get target rotation. You should see it right here at the very bottom. We are going to get the delta rotator of that, and get your character reference and drag off of it and get actor rotation, and just drag that into there. We're going to pull this off, pull this out a little bit. And we are going to split this, and I do believe it's the Z we need. So that was primarily why we were doing it. I think just because we really only needed to get the angle between the Z's. So with that out of the way, we need to pull off of here and do a branch. And so the turn angle is, well, the absolute value of the turn angle is greater than 130. No, I'm sorry, less than 130 is less than 130. If it's greater than 130, then we want to turn 180 degrees. If it's less than 130, then we want to turn 190 or 90 degrees, I mean. So yeah, let's see. We'll drag off here, do another branch. Now we will drag off of, oh, let's get the turn angle. And if the turn angle is less than 0, then we will turn left. So we need to create some variables here. These will be regular variables, so we will call it one TurnIPL90, and it needs to be, let's see, if we come over here to data and data tables, or should I say enums, let's see, grounded entry, mental movement direction, overlay state. Oh, it's a structure. Yeah, that's right. It is a structure. Rotate in place asset. I believe this is it. So if we open this up, we'll see we have our animation, our slot name, our slow turn rate, fast turn rate, slow play rate, and fast play rate. Yeah, so that's not the right one. This is the right one. Turn in place asset. Okay. Yeah, the other one's for rotation of another degree. So all it is it's a structure that's holding different variables, and this is how it'll look inside the blueprint. So you can create your own if you want. I'm going to use theirs. So what we need to do is we need to go to our variable type, and we need to type TurnInPlace asset, and we need to make it of type TurnInPlace. So under here, for this we will do -90, and the slot name. Remember we made that slot called turn/rotate. That's the slot we're going to be using. Yeah, turn/rotate. You can check it here if you're confused on your animation slot things. Our play rate's going to be 1.2, and scale turn angle. Yeah, we'll leave that to true. And so for this, we need to find our TurnIPL90, ALS in turn IP. You know what? Let's not do it that way. Let's go to our TurnInPlace folder, select it right here, rotate L90, just press the back button. Now we will drag that out and get it, and we need a local variable, so create a local variable, and yes, it's going to be of this type, and we're going to call it target asset. And now we will drag that out and set it, and we will connect that to it. And so if the turn angle is less than 0, then it's negative and we need to turn left. You can duplicate this right here and connect it to the false. And now we need to create another version of this. And we are going to call this one R90. So get it and compile, save it, expand this branch here. And for this one, we're just going to select the R90 there and press the back button and plug that up. And now we're using the same exact logic down here. So we will duplicate all this. And so if it's false but it's greater than 0, then we're going to turn it's less than 0, then we're going to turn left 180. So duplicate this and replace the last part with 180, and then duplicate this one and do the same thing, 180, and then this one will be here, this one will be here. Go ahead and plug them up, connect them, and then we'll change the animations. So we will press back on this one and then choose R180. Choose back on that one. Actually, we need to change this. The right needs to be positive 90. This needs to be negative 180. And this needs to be positive 180. Now, with that out of the way, we need to do the rest of our logic here. I want to do a reroute node here. I'm going to drag out and do a branch. And we're almost done with this part. So, let's see. Okay, so we need to drag out our target asset, get it, and split it. And so we need to see if this asset animation is playing slot animation. And we'll plug in that slot name right there to the slot name. And we'll do a not off of this. So if it's playing the animation, it'll be true and this will fire false. If it's not playing the animation, you know, you get it, then it'll fire true. So off of this, we need to play our play slot animation as dynamic montage, and then drag this out again and split it again. And so the slot name will be the slot node name, and the play rate will be the play rate. I think they used a blend time of 0.2 and 0.2, but I don't think an extra 0.05 is going to make much of a difference. And then the asset animation should be the asset. So, let's see. Okay. So we're going to drag off of here and do a branch. And then we need to get the turn angle. Well, we need to get the target asset. Let's split that and duplicate it. And we're going to see, let's see, the play rate. Yeah. So we're not doing a branch off of here. I don't know what I'm doing. Wait, are we? Yeah, we are. Okay, never mind. We need to get the target angle. We need to divide it by the turn angle, or the target asset animation angle, and then we need to multiply it by the play rate. And that should be our rotation scale. For this one, and for this one, it will be just our play rate. And so yeah, we do need a branch off of here. And let's see. So yeah, actually this right here, our turn asset scale turn angle, will determine if we are going to scale the turn angle. And let's move, yeah, you can arrange it however you want. Anyway, so if we are scaling the turn angle, then we're going to divide our turn angle, or the angle between where we're looking and where the mesh is facing, the direction the mesh is facing. We're going to get that angle, and we're going to divide it by our target asset animation angle. So either negative 90, 90, 180, or negative 180. And then we're multiplying that by the turn asset play rate. And that will give us a scaled value for our rotation scale. Now, if you remember, you can right click and find reference. This is being set right here. And so if this value, if we're not scaling the turn angle, then it'll be the play rate. So if we're not increasing the play rate, then this should probably not be checked. And so this should be 1, and so it won't modify the scale of the rotation amount curve. So that's that part. That's the end of this video, and I hope I didn't make it too long, and I will see you in part 4.